Good morning, students. Today we will discuss another problem. F of z equal to cos hz is analytic, and we have to find out its derivative. We can apply the formulas cos ix equal to cos hx, sin ix equal to I sin hx, d by dx of sin hx equal to cos hx, d by dx of cos hx equal to sin hx, and 1 by I is equal to minus I square is equal to minus 1. Then Cauchy Riemann equations are ux is equal to v by uy equal to minus vx. Based on this standard result, we can easily show that f of z equal to cos hz is analytic, and we can also find its derivative. Then f is equal to cos hz. Cos hz can be taken as by using the formula cos ix is equal to cos hx. Therefore, cos hx can be written as cos I into cos I into z is equal to x plus iy. X plus iy. Then releasing the bracket cos ix I into I square. Therefore, minus y. Therefore, cos ix minus y. Here we can apply the trigonometrical formula cos a minus b. Cos a minus b is equal to cos a cos b, cos ix cos y minus sin ix sin y. Plus cos a minus b cos a cos b plus sin a sin b. Then cos ix is equal to cos hx into cos y plus sin ix is equal to I sin hx. I sin hx sin y. Therefore, f of z is equal to cos hx cos y plus I sin hx sin y. From this, u is equal to cos hx cos y, and v is equal to sin hx sin y. Sin hx sin y. Therefore, this is equation 1 and this is equation 2. Then we can take the partial derivative to prove the Cauchy Riemann equations. We take the partial derivatives. Sin hx sin y. Sin hx sin y. Equation 2. We differentiate partially with respect to differentiate equation 1 with partially with respect to x. Therefore, ux is equal to cos hx differentiate cos h differentiate sin hx into cos y. Cos y remain constant. Then again we differentiate partially with respect to y, uy. Therefore, cos hx constant. Cos hx into cos y minus sin y. Minus sin y. Similarly, vx differentiate sin hx cos hx. Cos hx sin y itself. Then vy sin hx. Sin hx into sin y cos y. That is a partial differentiation ux uy and vx vy. Then take the Cauchy Riemann equation. First equation is ux is equal to vy. Here ux equal to sin hx cos y. Vy is equal to sin hx cos y. Therefore, first result is proved. Ux is equal to vy. Then second result, uy is equal to minus vx. Here uy is equal to minus cos hx sin y. Then minus into vx is equal to cos hx sin y. Therefore, we proved the Cauchy Riemann equation. Therefore, given function f of z equal to cos hz is analytic. F of z equal to cos hz is analytic. Next, we have to find out the derivative. To find the derivative, we use the formula f dash z. F dash z is equal to ux plus ivx. Here, ux is equal to sin hx cos y plus I into vx is equal to cos hx sin y. Then, sin hx, we know that formula sin ix equal to I sin hx. Therefore, sin hx can be taken as 1 by I into sin ix into cos y plus I into cos hx. Cos hx is equal to cos ix into sin y. 1 by I, we know that 1 by I is equal to minus I. Minus I into sin ix. into cos y plus I into cos ix into sin y. Sin y. Then taken minus I outside. We get sin ix cos y. Sin ix cos y minus cos ix sin y. When we take a minus I outside, minus I into sin x. Minus I into minus plus, then so cos ix into sin y. Then this is equal to minus I into sin x cos y minus cos ix into sin y. This can be written as sin ix minus y. That is equal to minus I into sin. Minus sin into I taken outside x plus iy. Therefore, minus I into sin I into x plus iy. When we opening the bracket, I into x, ix, I into I square, therefore minus. Therefore, when we take an I outside, x minus this become x plus iy. This is equal to minus I into sin I into x plus iy. Sin I into x plus iy എന്ന് പറഞ്ഞാൽ എന്താണ്? I into sin h into x plus iy. Sin h into x plus y. അപ്പോൾ ഇതിന്റെ കോംപ്ലിമെന്ററി ഫോർമുല I into I square. I square is equal to minus 1. Minus into minus plus. Therefore, sin h into x plus iy is h. Therefore, f dash z is equal to sin h. Therefore, derivative of f of z equal to derivative of cos h z is equal to sin h z. By using the formula ux plus ivx, substituting the values and simplifying, we get f dash z is equal to sin h z.